Hello and welcome. In this lecture, we're going to be investigating the concept of local variables, variables that only exist within a given function. And we're going to see how we can use this to set our location to a different value than the one stored in the my vector. Let's dive in. So up until this point, we have been dealing with variables that belong to a class. We've done this in Blueprint, and now we've done it in C++. And this means that the variable is alive for as long as the instance of the class. Each instance gets its own copy of a variable, but while the class instance is alive, the variable is too. Now, this concept that I've just talked about is actually got a name. It's called scope. What it means is how long does the variable live? And I've just described an instance variable. That's a variable that lives as long as a particular instance of a class. Now, there are other types of variables as well. There are variables that live as long as a function. Basically, when you call a particular function, that function runs, and as soon as the function finishes, the variable dies. So in C++, generally speaking, a variable is valid between the braces in the syntax. So it's a good rule of thumb. It's not always exactly correct, but the tick function, for example, we've got some braces here. And if we were to declare a variable inside this tick function, then it would only exist for one time the tick function is called, and the next time it would be created afresh. The moving platform, if we can see that if we have a look at moving platform.h, you can see the my vector is being declared within some curly braces that belong to the definition of the class, which is why these variables live for as long as an instance of the class does. So I'd like to prove this to you. So let's go into the moving platform.cpp. And let's create a local variable within this. So I'm going to create it in exactly the same way as we did when we're declaring it over in the header file. We're going to have an f vector, then the name of the vector, I'm going to call it local vector. And then we can set this a value right when we create it. We can do that using the constructor for f vector, or we can do it from another variable, just like we can pass a variable into a function. So we can first of all, I'm going to use the constructor method. So we're going to have f vector, and I'm going to give it a 1, 2, 3, and then a semicolon at the end of the line. So that now is a local variable. It only exists within this function, and it gets reset every single time the function is called. So if I were to do something like this, if I was to do something like we have on line 29 with the my vector being updated, we can have a local vector. We can have local vector.z is equal to local vector.z plus 1. And if I were to set my location to that local vector, it is going to be the same every single frame because we reset and start from the same location, 1, 2, 3, every single tick function. So this function really only exists locally. So I'd like you to try a little experiment as your challenge to set local vector from the my vector. So you're going to basically do, rather than setting it from the constructor, you're going to set it from the value that's currently in my vector. That's going to take a copy of that vector into your local vector. Then I'd like you to set actor location using the local vector, and because we're trying to update that local vector every frame, let's see what the effect is. Does the platform move? Would you expect it to? And go and try it out. Compile the code, play, and see whether it actually does. Pause the video and have a go. Okay, welcome back. So I'm going to, instead of using the constructor here to set the local vector, I'm going to set my vector instead. So we're taking the value that's currently stored in my vector and we're putting it into local vector. And then we are updating the local vector. We're increasing its z by 1 every single frame. And then I'd like to set actor location instead of from my vector. We're going to set it from the local vector instead. Now, what's going to happen in this case, do you reckon? Let's go ahead and find out. I'm going to hit the compile button and going to go ahead and hit play. And we'll see that the platform is still moving off to the right, but it isn't going up in the Z direction. So you can see that this isn't really having an impact, the increasing of the local vector, because it's being reset from the current value in my vector every frame. My vector, however, is still being updated every frame. The Y value is being increased every frame, and that's why we're seeing the movement over to the right. So one way we can see that this change to local vector is just local is by increasing this value from 1 to maybe 100. So we're adding 100 to the local vector value. We can go over and compile and then hit play. And what you're going to see is that the platform's actually 100 units higher in the air. Let's just take a second here and eject out with F8 and pause the game with the pause button in the main toolbar. And then select our moving platform to have a look at it in the details pane. To do that, I'm having to actually click on it in the viewport for some reason. Sometimes it doesn't work just clicking on it in the outliner. And I'd like to point out to you that the value in my vector, the Z value in my vector, is 100 units less than the Z location of the transform. So you can see that adding to that local vector has had an impact. We have got our location 100 units higher than the location in the my vector. And what's really great about local variables is that when the function has finished its particular execution, they get cleared up and reset. So you can always know what to expect with a local variable. You always know what value is going to be in it, unlike a class variable, which can be updated anytime from any other function. So we're going to be putting these local variables through their paces in a few lectures' time. Let's dive on.